Writing vertex form equations. Okay, so you are able to write the vertex form equation of graphed functions by following these steps. So your first step here is you're going to find the coordinate of the vertex, and then you're going to put it in the equation for h and k. Then the only thing after that you're missing is that a value. So you're going to pick a coordinate point on the line other than the vertex, plug it in for x and y, and then solve for a, and then rewrite your equation with your newly found value of a. So let me just jump into that right now. It'll make more sense as we go along, okay? So remember, this is the form for a vertex form equation. And in order to write in vertex form, you obviously need the vertex. So let's look at this graph and identify the vertex. So I can see it's right here. The vertex is at -2, -3. So let's put that vertex in the equation for h and k. So I'm going to have y equals, for now, I'm just going to write a, parentheses, x. Now, since it's -2, remember, I'm circling here, it's opposite h. You got to do the opposite of h, which would be +2. +2 squared, because h was -2 here, right? So we're going to do +2 and then -3 because that's our k. So remember, this is h, this is k down here. So remember, do opposite of h, and then whatever k is outside the parenthesis like that. So look at that. We got it somewhat in vertex form right now. It looks really good. We identified the vertex. Now the only thing we're missing is what that a value is. So now we have to figure it out. So let's go ahead and let's try to get that a value. Now the steps and the notes are above, but here's how you can get the a value. You're going to pick another point on the line, any point on the line, and you're going to substitute it for x and y. So I'm going to pick that point in blue. I want to pick somewhere it crosses nicely. This looks, let's do here. So that point is at -4, -1. So let's substitute that in the equation for x and y, because that's an x and y coordinate, correct? This is an xy coordinate. Let's substitute it in for x and y in the equation. So y is -1. X is -4. And now we've substituted in there. So now we have a one variable equation. We just have a to solve for. So let's do some simplification. I'm going to rewrite the -1. And then inside that parentheses, -4 + 2 is -2. -2 to the second power is 4. So where it says a times parentheses -2 squared, I'm going to change that. Let me rewrite the -1 first to 4a, right? Because -2 squared is 4. And I'm just going to put that coefficient in front, that 4 in front, because obviously that's usually what you see equations written as, with the coefficient in front. So -2 squared is 4. So I'm going to write 4a, and then I have -3. And look at that. We just have a nice little two-step equation. So I'm going to add 3 to both sides, solve this. That's 2 equals 4a. Again, I'm solving for a, so I can divide by 4 now. And 2 divided by 4 is 0.5. So you can use that for a. But I'm going to leave it as a fraction. So 0.5 is a fraction. It's just going to be 1/2. 2/4 is just 1/2. So there we have it. We have a now. I'm going to underline that. So this is great. We have our vertex. We know what that is. We now have a, so we can write our final answer. So I'm just going to put a into this, and we're going to be good. So it's going to be y equals 1/2 x plus 2 squared minus 3. That is the equation for the graph. 1/2 x plus 2 squared minus 3. That a value should be positive, right? It's opening up. 1/2 is positive. Should be good. Okay. Let me show you number 2. All right. First step, I want to figure out what the vertex is. So let me calculate that. This vertex looks at 4 comma 1. So I'm going to write this equation in with the vertex in it. So I don't know what a is yet. I'm just going to write a parentheses x. Now it's opposite of that positive 4. So it's going to be x minus 4 squared. And then just positive 1. It's only opposite for the inside the parenthesis. And we're kind of halfway done. We inputted the vertex. But now we have to figure out what a is. So we're going to pick any other point on the graph. Doesn't really matter which one. I'm going to pick let's just pick this one. That is 3 comma negative 1. Okay. So negative 1 is our y. And 3 is our x. So now I have a one variable equation where I can solve for a. So negative 1. 3 minus 4 is negative 1. Negative 1 squared is just positive 1, right? So this is going to be negative 1 equals 1a. A lot of ones going on. And then we have a two-step equation. So subtract 1. That's going to be 1a or just a. I don't need to write 1a, right? I can just write a. Negative 1 minus 1 is negative 2. So a is negative 2. So to rewrite my equation, I'm going to have y equals negative 2 parentheses x minus 4 squared plus 1. And it makes sense that that a value is negative, right? Because it's opening down. Okay. Hopefully those two examples are enough. I'm going to jump to some tables. And the tables, the process is basically the same. But you can try the rest of the graphs. Let's do it with the tables. Write the equations of the following quadratic tables in vertex form. So just like with the graphs, we have the same sort of concept. We are going to have to get the vertex first. Now, remember when you think of a vertex, it's, look at my hand here. It's either the maximum point, so like up at the top, so where it changes from increasing, then down to decreasing, or it could be the minimum point when we're going like this, where it's going from decreasing and then it goes up to increasing. So it's that point where it changes. It changes from either increasing to decreasing or decreasing to increasing. So as we're looking at this table and the y values, don't highlight any of this, but if we're looking at the y values, we got to figure out, okay, where does it hit either that top point or hit that bottom point? So if you look at it, it goes 4, negative 5, let me re-highlight that, 4, negative 5, negative 8, then back up to negative 5, 4, and then way up to 19. You see that? Starts at 4, goes down to negative 5, down to negative 8, then it goes back up to negative 5, then back. So that tells us our vertex is right here. Negative 1, negative 8. That's that point where it changes from decreasing and then it's going to start going back up. So that is our vertex. That's how you can see the vertex from a table. So let's put it in the equation. So I'm going to have y equals a x opposite of that x value. So opposite of negative 1 would be positive 1 squared minus 8. Now all I need is the a value. So I'm going to pick any other point in the table. It's the same thing as the graph, right? We're just picking another point. It's nice in the table because I can just pick whatever one I want. I can pick any other point. So why don't I get fun with it? I'm going to pick the 219. It might not be the best one to pick because 19 is a big number, but who cares? Let's do 219. So 19 for y. Whoops. And then 2 for x. And now we have a one variable equation. I just need to solve for a. Let me zoom in. So 2 plus 1 is 3, right? So I'm going to make in that parentheses a 3. 3 squared is 9, so I'm gonna write 9a. And now I have a two-step equation. I'm not going to show the full step here. I'm going to add 8 to both sides, right? So that would be 27 equals 9a. And then I'm going to divide by 9. So 27 divided by 9 is 3. So a is 3. So to write my final answer, y equals 3 for a, x plus 1 squared minus 8. That is the function. Okay. Let me show you B. So I'm going to find the vertex. So it looks like it goes 4, 9. I'm looking at these values. Remember, the vertex is where it changes from increasing to decreasing or decreasing to increasing, right? So if you look at those values, it starts down at 4. It goes 4, 9, 12, hits 13, then goes back down to 12, then back down to 9. So it looks like 13 is that peak. 13 must be the vertex. So this 5, 13 is the vertex. So let's begin. Y equals a parentheses x opposite of the 5. So since it's positive 5, it's going to be minus 5 squared, and then plus 13. Next thing we need to do is pick another point in the graph, or sorry, in the table. Doesn't matter which point we pick. Why don't I pick... I don't know. I'll pick the 3, 9. It don't matter. So 9 in for y. And I guess I should be using, if I'm being honest, I should be using g of x, not y. I don't know. It's not a big... As I write my final answer, it's going to matter, but okay. 9 equals a. 3 is x. Minus 5 squared plus 13. 9 equals 3 minus 5 is negative 2, right? So negative 2 squared plus 13. Negative 2 to the second power is positive 4. Let me rewrite the 9 first. It's positive 4. I'm going to put that 4 in front as a coefficient. So 4a plus 13. And now I have a nice two-step equation. So I have 4a plus 13. Trying to solve for a. I'm going to subtract 13 from both sides. I'm not going to fully show it. That's going to be negative 4. And divide by 4 would be 1 is a. So my final answer would be g of x equals negative 1. I could put, I'm just going to, like, you could put a 1 there, but a lot of times in math, they don't show that 1 there. So I'm just put negative x minus 5 squared plus 13. And there you go. So that's how you write it in Vertex form from a table. It's actually the same method as with the graph. Okay. Let me show you a little pro tip. If you made it this far in the video, here's a little pro tip. Finding that a value, you can sometimes just see it in the table. And you might be mad at me for showing you this now. But if 13 is our vertex and you displace 1 from the vertex, see, look how much that went from 13 to 12. Didn't that go down 1? And a value is negative 1. Look at that. Little pro tip. From 8 to negative 5, didn't that go, isn't that adding 3? Isn't a value 3? So you can kind of see it sometimes just doing that. Let me show you a graph. From the vertex to this next point here, then if you displace 1, again, it's only if you displace 1, it goes down 2, right? And the a value is negative 2. Look at this one. If you displace 1, it looks like it went 1/2. And isn't the A value 1/2? So you can kind of see it just in the graph. Now, I didn't want to show you that at all earlier, because what if it's like a crazy fraction? What if it's 2/3 or even 3/5? It's going to be impossible to estimate it on a graph. So you need to know this method of plugging in a point. So just keep that in mind. Number 8, I guess I'll get you started on it if you need it. So it says after, I'm not going to do the whole thing. After 1 second, the ball's at 23 feet. So why don't I do an XY table or something? So at 1 second, it's at 23 feet. And then after 2 seconds, it reaches a maximum height of 30 feet. So that should already tell you what the vertex is. It literally says the maximum. That's after 2 seconds. So I got 2, 30. After 3 seconds, the height of the ball is 23 feet. Okay. So, this would kind of be a table of values, and, you should identify this as your vertex, and then you can pick either one of these other points to write the equation. And I don't want to do that one for you because it's just like the table. Okay. So good luck.